All right, so in this video, we're going to be going over how to say the names of our ionic compounds. And a lot of it should be review. We always say the metal first and the non-metal second. And the thing that we'll notice is a pattern here is our non-metal, we change the ending to "ide." So I'm going to be answering the question, why don't we change anything with the metal? And why the non-metal do we change it to "ide"? So the metal stays the same because if you remember in metallic bonding, our metals wanted to lose their valence electrons. In ionic bonding, our metal wants to lose its valence electrons. Metals always want to lose their valence electrons no matter what. So nothing's really changing here. They're still doing their same thing. So it will be just the metal. However, our non-metal wants to gain electrons, but it can gain electrons in different ways. So that's why there's a difference between a chlorine atom and a chloride ion, and they act very differently when it gains that electron. So that's why we give it that different name. There's a difference between a chlorine, which is neutral and has 7 valence electrons, and chloride, which has a negative charge and has a full set of valence electrons. So when writing these out, we could see we'll have, and we've seen this one so many times before, we got NaCl would be sodium chloride instead of chlorine, magnesium and oxygen would be magnesium. You see the metal doesn't change. Oxide instead of oxygen. And for this one, calcium chloride with the 2 chlorides, you don't have to say chloride 2 in the name. So this would still be calcium chloride. And we would know, just because the charge is +2 on calcium and -1 on chloride, we would know when we wrote the formula unit down that it would look like this. For the next one, we got potassium oxide. And aluminum oxide. And this one is a little different because when we write it down, we need to write down the charge on this iron right here. So we would have to say iron 3 oxide. And you might be like, why are you putting iron 3 when you only have 2? And let me go back to our example over here. If we had iron 2 oxide, you'd only need 1 of each. It would balance out just like that. 1 iron, 1 oxide ion. But if you have iron 3, you would need those 3 oxide ions and 2 iron ions. So because it's iron 2 oxide 3, I know that I'm dealing with iron 3 right there. If I had, and we could write this example down, FeO, I would know that I had iron 2 and oxide there. So for that one, I would write iron 2 oxide. In this video, we're going to be writing out formula units based on the name written out like this. So the first thing we have to do is figure out what the charges of these ions are. So we know calcium is in group 2, so it has a 2 plus. And fluoride is in group 17, so it has a 1 minus. So we can get both those out here. And we need to make our charges balance out. So to make these balance, I got +2. I need them to get -2 here. So now I got +2 and -2. So they balance out. So the way I can write it is calcium, fluoride, and I got 2 fluorides. So my next example, I'm going to be taking a look at some of my transition metals. That's where it gets the most complicated. So this one tells me my charge. It does not tell me how many copper I have in my formula unit. So it's telling me my charge on my copper is 1. And oxide would be oxygen with a 2 minus. That is the biggest mistake I see students making. They think 1 copper in the formula unit. It actually means the charge is +1. So we're going to put copper 1 right there. And oxide here. And to balance our charges out, I'll need to put 2 copper in. So the way I write my formula unit would be copper with a 2, oxide. So I want to restate this mistake because I see it a lot. When I have copper 1, that means the charge on my copper is +1, not how many I have. So if you see this copper 2 oxide, it's the same as copper 1 oxide, written out like that. This tells me how many I have here. This tells me the charge of my copper up here. All right, so let's do another example with a transition metal. We got copper 2 oxide, so something very similar, but this tells us our charge. So we could have copper there, oxide here. Oh, let me make sure I write my charges out here. So that 2 means 2 plus. So now when I write this out, I just have 1 of each. So remember, this 2 means I have a +2 charge, and the number I have here is how many I have in my formula unit. We'll do a couple more with these transition metals because they're the ones it's trickiest with. Iron 3 nitride. This tells me that my charge on my iron is +3, and nitride and -3. So you can see these balance out nicely already. Our charges nicely cancel out. So the way I would write this is I have 1 of each. So I would have iron nitride. And now we'll do our last example. What about iron 2 nitride? So if I have iron 2, that means my charge on my iron 2 is a 2 plus, and our charge on our nitride is 3 minus. So our charges don't balance out, so we can't just have 1 of each now. So we need to add more plus, and that gives us 4. So then we have to add more minus. And we balance out like this. So we would write our formula unit Fe3, because we have 3 of them here in our compound, and we have 2 nitrides, so N, oops, it's getting a little messy here, N2. So again, I'm going to recap the main part where students make a mistake. This right here is the charge we see in our ion. And this number down here is how many ion we have in that compound.